let's suppose we want to solve the integral e to the x times cosine x dx. Now I'll do this by complex substitution. So let's do instead let's look at the integral e to the x times e to the I x dx rather than e to the x times cosine x. This is equal to the integral of e to the x times cosine x plus I sine x dx. And as you can see here, our integral is the real part of this integral. We're looking for a part here. So this is equal to e to the x cosine x dx plus I times the integral of e to the x sine x dx. So what we want is the real part of this. Okay? So we want the real part of the result. So that means that if we solve e to the x, e to the ix, which is equal to e to the x times 1 plus I dx, this is equal to, now the integral of this is going to be 1 over 1 plus I, and then e to the x times 1 plus I. So this is the result. So it was very easy to get. Now the purpose here is to get the real part. So what we're looking for, the real part of this solution. So the real part, let's first simplify this fraction here. So this is equal to 1 plus I, multiply top and bottom by 1 minus I, and this is equal to 1 minus I times, now 1, so multiplying these two, we get 1 times 1 is 1, and I times minus I is equal to minus 1, which is equal to plus 1. So this is equal to 1 minus I over 2, and then we get the remainder is e to the x times e to the ix. So this is equal to 1 minus I over 2 times e to the x times cosine x plus I sine x. And now we look for the real part. We will look for the real part of this. So this is equal to 1 over 2 minus I over 2 times e to the x times cosine x plus I sine x. Now let's see, let's multiply e by this guy, so we get e to the x over 2 minus I e to the x over 2 times cosine x plus I sine x, and this is equal to, now let's see what's real and what's imaginary here. This cosine times this e to the x over 2 is real, so we get e to the x over 2 cosine x. This e to the x over 2 times the I sine x is going to be imaginary, so we ignore that. Then this I e to the x over 2 here times the cosine is imaginary again, and so the only real part next are these two guys here, minus I e to the x over 2 times I sine x. So this is equal to I sine x times minus I e to the x over 2, so that's equal to e to the x over 2 cosine x. Now minus I times I is equal to 1, so it gets plus 1 e to the x over 2 sine x. And then finally the result is e to the x over 2 times cosine x plus I plus sine x, no I there. So this is the result for the integral of e to the x cosine x dx, and this was all using Euler's formula.